So good morning, everyone. Today we are talking about GraphQL and observability. And what that means we will explore. So that is my talk with the least slides I have ever made, because it's a bit of exploration we will do and see what the problems are that we face at production with GraphQL and how we can make them visible before the support calls or the customer calls into our company and we get under pressure. So a lot of the things I will be talking about and we look at will actually also apply to other systems. Like you could use them in REST or you could use them with gRPC. But with GraphQL, they are a bit special. And typically when I do start with my GraphQL introduction talk, I will start with this slide. That is the least complex GraphQL query I could come up with. It asks for the currently signed in user. So what does this have to do with GraphQL production issues? So the thing with GraphQL is that we reversed the responsibility between the back end and front end. Like the back end is not anymore deciding what the requests will look like, meaning the consumer will decide what the requests look like. So the front-end developer designs requests that are good for his or her backend, for his or her components in the front end. And that's good, because front-end people or data scientists, they will be happy because they can shape their request to their needs. But it also is a problem. But it becomes a problem when we create larger requests. And maybe in the back end we start to introduce new components, and the characteristics of requests that we had suddenly break. Or maybe just because we drill into more connections in our GraphQL requests, that our performance suddenly degrades. So typically, like our GraphQL setup, typically like Facebook introduced it, is a thin layer of GraphQL over our business layer. And in that setup, it's easily controllable how performance could develop over time. But typically, what we see in enterprise production environments are more complex scenarios, where we have GraphQL as kind of a gateway technology on top of domain services or microservices. Like it's very common that you have an existing service infrastructure, maybe composed of REST services, gRPC services, Thrift services, whatever you have. And then we put on top of that GraphQL to make it easier accessible. It's also a very easy way to modernize your API. You have your existing infrastructure, you put GraphQL on the top, and then you start renovating. Yeah, that's a typical, like you would typically put things like these domain services on top. But when we go further, and that is, for instance, if you look at Netflix, they have a setup where they have a GraphQL gateway, and they split this GraphQL gateway essentially into domain GraphQL services. So why do they do that? Essentially to enable teams to work on this single graph in parallel. So each team in Netflix owning a topic has its own GraphQL server. And beneath this GraphQL server becomes even more complex. They have a lot of microservices they use through Thrift. So if you think about such a setup, it becomes very difficult to say who broke what, or what caused a performance degradation in our system. And how should we debug such a degradation of performance? and find out where the error actually happened. So this talk is about observability, but it's also very much a talk about finding production issues in GraphQL setups. And to start with that, we have a demo application we use in a lot of our talks. It's our cryptocurrency app. And this application actually has an issue. And we're going to find what it is. So how would I approach even? Like, let's say I get a call from our support and they say our servers are heavily under pressure. So what would I typically do? Maybe I would refresh my site locally and look how it performs. But typically on my local system, it always works. It's quite fast. Works on my machine. So how do we approach that? So maybe the first thing we could do is looking at our output. What is happening when I execute something here? It's a typical poor man's approach to finding an issue. It's running it locally, maybe looking at the typical use cases and looking at what we have in the log. And it doesn't have to be a console log. It could also be a serial log or what have you. It's a typical approach that we would essentially do. And what we can already see here is that we are doing a couple of SQL requests. So the single request for one cryptocurrency here cost one SQL, two SQLs. It also caused a REST request and one REST request, two REST requests. Doesn't look so bad actually. Is what we maybe even expect. So how would we go further with that? Because that's a problem. Locally, we don't have the scale, like we don't have the pressure of a system. And that's why we don't have these issues that we have when we have parallel requests. So back in the beginning when we did start with GraphQL, Apollo, it's a company that was one of the first doing building GraphQL products. They came up with something they called Apollo tracing. So in this case, we would set up our server, our GraphQL server, to expose performance insights in the response of our request. And we can do that by, for instance, adding it here, add Apollo tracing. By the way, Apollo tracing is kind of deprecated. So we shouldn't use it anymore. But I'm still showing it just to have an idea how this developed to where we are going. Let me restart that. That, by the way, would be a very dangerous configuration to always expose tracing data in our results, because they will blow up our GraphQL results. We shouldn't do that. But just to make a point. Okay. And we could use like something like GraphQL Playground now to write GraphQL queries. Let me just do one simple one, and then we really drill into something more useful. Like I could get the currently signed in user. And if I fire that, you can see I get here these performance insights into my response. Actually, my response would look a lot bigger, but the IDE essentially cut it out and visualized it here in my tracing view. What it does is give me kind of insights in how long a resolver executes. So I would, in this kind of work, go to my UI maybe here, refresh it, and capture this request. This is my GraphQL request. And let me just copy it out. Copy value. And I could go over to my IDE here, copy it in. Get also the variables here. Copy them also over. Then execute this thing here and have a look at the performance characteristics. And what I already can see is that price change kind of is the expensive part of my request. The problem with this approach is that I'm exposing internals into my response. And I would have to do that on production to see if there is something wrong in production. And the third problem here is that doing that is kind of a pull approach. I have to execute something to get insights into something. And that is kind of bad because I want to be informed when something goes wrong, when something goes out of the ordinary. And also, I don't really see what is really wrong. I see price change here is a problem, maybe. We don't know yet. But I cannot see, is that my resolver that has a problem or an underlying system? Okay, let me go back to slides. So this is when we start thinking about observability. And observability was very difficult to achieve until very recently, I would say. And I say that because I was working on a major project in Switzerland for a big insurance company, and they would build their own observability platform because things like OpenTelemetry didn't exist at that point in time, like let's say 8 years ago. So what they would do is inject everything that you have, like HTTP requests and service bus messages and what have you, and add correlation IDs to it. And then track these and aggregate logs of all these services and build really a nice platform on top of it to make it visible. But it costs dearly. We had, in the first 2 years, 2 developers just working on that platform, not working on our business code. So you could do observability, but it was very, very expensive. So what does observability mean? Observability allows us to get a grasp on how our system performed. What is the state of our system? And it does that by taking into account a lot of things like logging, metrics, and tracing. And tracing is always when we essentially hit boundaries, like go from one service to the next, then we create things that we call spans around these intersections. That is where OpenTelemetry comes in, and OpenTelemetry allows us now very easily, since .NET 6, to make our systems observable. And OpenTelemetry is not just like bound to a certain vendor, it's an open standard. And it standardizes how we deal with logs, traces, and metrics. And OpenTelemetry is actually not something new. It was merged out of 2 projects. There was a project Open Tracing and Open Sensors, started actually by Google. And they focused on different aspects of the observability scalar. So these projects were at one point merged, and then companies like Microsoft, Meta, and so on got behind these projects and started building them into their platform. So Microsoft is a big contributor to this project. So if you go to the GitHub repository of OpenTelemetry, you can see that Microsoft is one of the biggest contributors there. So one warning here, OpenTelemetry is still not released for the .NET platform. We are at the moment at RC5 or something like this. I can have a look in a minute. But we are very close. So if you start today with observability, go for OpenTelemetry. You could use a vendor login, so like companies like Elastic, they have APIs that are released that you could just plug in, give you observability, but with a vendor lock-in. So you could go this route, but the better route is to go with OpenTelemetry, because then if you decide Elastic is not good anymore for us, we want to use Honeycomb, for instance, then you can swap them out. So what is OpenTelemetry about? So with OpenTelemetry or observability, we want to instrument our components and generate like data to validate our system. And that data we want to collect and export. And these are the major components in OpenTelemetry. And the export component essentially allows us to swap out the vendor. So we have exporters for Jaeger, we have exporters for Elastic, Honeycomb, and whatever. A very important term in OpenTelemetry, you hear it often, but in the beginning you don't know what it means. It's MELT, and that means metrics, events, logs, and traces. So what are these? Metrics are essentially indicators, often represented by integers, that give you an idea how much requests go through your system or how much memory is used, like these little indicators where your system pressure-wise is. And then we have something like events, and that's if you think about a machine, we have events. If you push a button, something happens. That's typically an event that happens in your environment, in your components. And then we have the typical logs and traces. So an OpenTelemetry setup looks a bit like this. We have our application. Then in our application, we have a lot of API that does something. And we report what it does or where we have intersections through the OpenTelemetry SDK. The output of these things are processed and then put to the exporter. You can already have an observable solution by just putting OpenTelemetry into your application and exporting it to an OpenTelemetry backend. In a production environment, we would use more something called the collector. And the collector is another service component that you, in a Kubernetes setup, could spin up in a Docker container and then push the telemetry data to that collector. And it helps you in the sense that not every application or not every container of you batches things to the OpenTelemetry backend, which would usually go through the internet. But the collector essentially helps you to just push to a local service and then batch from there to your OpenTelemetry backend. What we will look at is Elastic as an observability solution today. But as I said, that is interchangeable. So you can take the knowledge from this talk and apply it to other solutions. So let's have a look at how we would put that into our GraphQL server and how that gives us insights. So the first thing is that we kind of need to identify our service in the OpenTelemetry world. And before I show that, just because I said it's still release candidates, at the moment we are using OpenTelemetry RC4 and the OpenTelemetry core RC9. You can see it's already release candidate, but still not fully released. Okay, so the first thing we put in is like an identifier for our API. And for this, we can use something called the resource builder. And with that, we can essentially describe some metadata about our service. So we call our service Coin API here. And we can give it a namespace. I give it a namespace demo. And if you have a lot of services in your backend, then this makes it easy to identify what service we are talking about or how to filter to that. In this instance, I have version 2 of my service here because we maybe made a change that degraded our performance, and we're going to find it now. And I also provide some attributes here that give me an idea in which environment I'm in, and we can see in a minute how we can use it in Elastic to filter between production and environment, or even between when we change from .NET 6 to .NET 7 or so on. You can put more custom data in here depending on your needs, but these 3 items here are picked up as native metadata by Elastic. Okay, with that we have described our API. Now let's set up OpenTelemetry. And OpenTelemetry we set up as a service. So we focus on 2 things here, metrics, and I just put here metrics in, and we have HTTP client instrumentation and ASP.NET Core instrumentation. And these actually come from packages that are already prepared. You can see here's the OpenTelemetry instrumentation HTTP. This is a package by Microsoft that gives me metrics and traces for the HTTP client. So I don't have to inject any correlation IDs. And also, I also get for free here the ASP.NET Core instrumentation. There are instrumentations for the data drivers, like I know that Shay from the Entity Framework team, he built telemetry into the Postgres driver, for instance. So you get also automatic telemetry out of these things, like all the ADO drivers. Jimmy Bogart built telemetry for MongoDB. So there's a package out there. If you're using MongoDB, you just plug the package for it in and you get telemetry events. So there are a lot of packages already ready and finished, and you just plug them in. For Hot Chocolate, we built the telemetry. So we have this Hot Chocolate diagnostics package here, which will automatically provide telemetry events for our system. Okay, let's put some more things in. So we have the metrics. Let's also put the traces in. For that, we have this add OpenTelemetry tracing here. We are using, again, the HTTP client instrumentation, the ASP.NET Core instrumentation, and in this case also the Hot Chocolate instrumentation. The next thing is we are collecting this instrumentation, but we also need to expose it. So let me get rid of Apollo tracing here, and let's put in add instrumentation, because instrumentation also will cost some performance. That's why we don't put them in by default. So it's not free, but it's not so much as to not have it. So I would suggest put it in. Okay, with that, let's just start our service again. And just for the connection setup here, so I have an endpoint here that is pointing directly to Elastic. And Elastic has, in the meantime, implemented the OTLP protocol. OTLP is the OpenTelemetry protocol. And we have that as an exporter here, so we can natively talk to Elastic. Okay. Good. So it's 2 things that you actually need. If you just want to plug it in for testing purposes, you just put in here the Elastic endpoint, and then you need some headers, an API key to your backend, and then you're good to go. It will report. Okay. So now that we have that hooked up, it's working, we can go to our API, refresh it maybe a couple of times, so we get some telemetry data to batch to our Elastic Cloud. Let's just do a couple of things here. Okay. And then let's go to Elastic. So typically when I start talking about Elastic, many people think of Elasticsearch. but they have quite advanced, and they built essentially their observability platform on top of their Elasticsearch. So they can easily aggregate in a nice fashion performance data. So let's go in. Okay, and you can see Elasticsearch is their main product, and then they have here the observability solution. That's where we go in. So the first thing we can do is have a look at the service map here. And that is interesting because we can already I just refreshed it a bit. We already can see that we have our coin API that we just created. And that actually uses another API, which is the price API. And the price API actually is an Azure function. So that has some telemetry to the Visual Studio service. Who knew? And we also have like here Postgres. And I said Postgres is natively integrated with telemetry in .NET. So we already get like an idea how our system even looks like and is connected to other systems just by plugging in OpenTelemetry. And as I said, like the data here, we can also switch between production and development. That's from our metadata. If I put some other environment in, it would automatically show up. And you already can see that my system already warns me there's an anomaly detection. So something has changed in the meantime in our system that kind of is not right anymore. So there are a couple of other things that I can have a look now at, and that is services. That's essentially the list of my services I can drill into. There's my price service and my coin API. My coin API is my GraphQL server. Let me just filter into my development here. So what I can see here is there's a GraphQL request, which kind of is not so helpful. So we need maybe to do a bit more to be able to explore that. So why is that aggregated like this? So by default, the telemetry events are aggregated under the HTTP middleware. And that kind of makes it difficult to see what GraphQL request is behind that. And for that, we have in almost all OpenTelemetry integration something that we call an activity enricher. Sorry. So for Hot Chocolate, we have designed that as a class where we can say, okay, we need a custom activity enricher. Yes. And I show you what that is. So the activity enricher gives us access to enrich the instrumentation events from GraphQL with extra information, or rewrite the telemetry event tree to our needs. In this case, we're optimizing a bit for Elastic because Elastic is what aggregates it in that way. So what we want to do in this case is say, okay, for Elastic, we enrich a bit how we create the root name of our graph, and we actually remove the current name from the root activity. You can see I get in my enricher here the activity for GraphQL, and then I get the root activity from the ASP.NET Core middleware. And what we are going to do is just override it with the current display name that we use in our GraphQL activity. You will see in a second what that actually means. So the next thing is that I can hook up my activity enricher at Singleton with the dependency injection, and then by this replace the standard activity enricher. So why activity enricher? Because the API to provide telemetry data in .NET is the new activity API that Microsoft introduced in .NET 6. You also have activity enrichers in, for instance, ASP.NET Core events. I think they have that as an overload here. Let me check. Not here. Here. Ah, there. Yeah. Like they pass it as a delegate, so you can get a handle on their activities and then rewrite them and stuff like that. Okay. With that, our API will restart. Let's have a look at the telemetry events again. And let's produce some. And it should. I'm just doing a couple of, because it takes a couple of events to batch to my backend. Let's refresh that. Okay. And what we can see now, what we should see, let's refresh that. Sometimes takes a second. And that is development. I hope. If not, I will just spawn some from production. We just put that in. That was the crypto. No relay. It's sometimes difficult to have these live demos where you have cloud infrastructure involved. So let me just get some events from our deployed application. Okay. Yeah. That is a dashboard query, but we actually wanted to analyze the Bitcoin query. Just get some data for this. Then we have a look into it. Okay, that should be enough. Refresh that. If not, we take the first one, doesn't matter. Okay, so what we did with the display name essentially is to rewrite our route request here. And now we get an information that this is the GraphQL route. And we are actually executing a query, and the query is called dashboard container query and gets something called ticker and featured. And we can now look into that tree. This is actually my GraphQL query, all the relevant parts of my GraphQL query. So I can see, like, in the metadata, that we are actually executing this query here. I could paste it out, it's not optimally formatted, but I have access to that query. And I also can see like the relevant fields that we are using. For instance, I can see there's the field ticker that takes some time here. But actually the field ticker doesn't exist in my backend. It's aliased. But I can have a look at the metadata and then see that's actually the field assets. So it was renamed by the front-end developer to ticker. And then I can drill in. I can see here a couple of price resolves, and we kind of had the notion that price could be the problem. And then we can see that price actually is badged to another service, that's our price service. And the price service actually has an SQL here, which first does a count operation, and then does some other information to fetch the data. So you get quite an idea what is happening now here. And we get this idea even without actively looking at it. So anytime any request goes through this, we get these aggregated nice graphs here now. We can see that one request actually doesn't involve just a single SQL query. You can see it's 1, 2, 3. There's an more expensive SQL query we can see. We could also drill more in the details of this request data, get an idea what is involved. Like there, we even would get hints about missing indexes. That's a typical thing we find when we look at performance issues. it's not only that something is wrong, like a programming mistake, it's often like forgetting to set an index. Okay, so this makes our system already much more transparent. So let's go back to my traces and see if we actually by now get the trace I'm looking for. Yeah. View container, dashboard container, that's actually the request I wanted to have. Let's see if we also have that for development. It sometimes takes some time. That's why I walked you through the other one first. It's a shame that we didn't get this from my local deployment. Okay. So this is the actual request from the Bitcoin page. It's called also view container, but you can see this is a root field, asset by symbol. And if we drill into that, oh, not on production. Come on. And we get now an idea why my request to get this Bitcoin could be a problem for our production environment and why it puts our system under pressure. So we can see that there are 4 SQLs and 1 HTTP request to get the data for the simple coin. And we could optimize that to maybe get rid of this count request here, because that kind of seems suspicious, and we have that even 2 times. Okay. And like, just let me have a look in here, because that is our field to fetch the asset. Let's see if we can see, no, not this one. Let's see if we can see also the variables. Typically, you also get the inputs for what we send to the backend. But no, we don't. Doesn't matter. Okay. So what we could do is now look into our resolver that actually is affected in our solution. So typically, we look at the telemetry data, then drill into, we kind of get an idea where it should happen, this mistake. I know it because I built it in. In our concrete case, it's in the asset price node. That's what we looked at with the not so nice SQL. We actually refer here to a new version of the asset price service, and this asset price service does some extra SQL runs to get the counts and stuff like that. So we could now fix that and replace that maybe with a data loader that fetches more efficiently the data or some other things. Okay. That's kind of how you can use Elastic to make these things visible. There's one more aspect here, and these are custom metrics. And I haven't talked about this so far. So in order to use these anomaly detection, and we saw that in the Elastic portal here, like there's an anomaly detected, and we could create some jobs now to kind of send an email if there's an anomaly detected and inform a developer ahead of time. Like maybe our system did just for the same request 1 SQL request always. Then the system can record that, can see that pattern. But then when we finally just update the backend infrastructure, and now there are 5, 6 SQL requests happening, then Elastic could write an email to developers. The characteristics of your request actually now changed. Is that right? Could be right. I mean, we are updating, could be even now better performance. But if it's not right, it would be good if someone just reviews it. So we could create some rules here. Just go here into our metrics. See if we have some. Infrastructure metrics, yeah. Yeah. So we could create a rule that that gives us an indicator, like when this and that goes out of the normal range, then send me an email, for instance, or do some other things. Like you can put actions on that here. Could write a Teams message. So there are a lot of integrations here that you could use to make developers aware that something goes out of the ordinary. So in order to make that very simple, it's good to have something like metrics, custom metrics, where you can see that something goes out of the ordinary. It's much simpler than looking at the tree. So for this, we already have here the built-in metrics. So we could look at memory, for instance. But in our concrete case, we are looking at GraphQL problems. So what we can do with hot chocolate is introduce a log interceptor and then put on that some metrics. So let me put in a new class here. And then, not this one, wrong snapshot. It's the meter. I'll take this one. Doesn't matter. So this one is the execution diagnostic event listener. We can use that to essentially hook into internal hot chocolate events. For instance, the request size. A good indicator if our infrastructure is getting under pressure is maybe how many requests go through the system. So we could say, all right, and then execute request. And then we could put in a meter here. And that is a new API that we have from Microsoft. That's actually the template I wanted to have. Thank you. So a meter, this Microsoft introduced with the activity API. In this case, we can give our meter a name, demo.graphql. It's version 1. In this meter, we create a counter here. There are different kinds of meters that I could create. In this case, we keep it simple. So, and then we can add like here, always one, we have one request, so we add one thing to our meter. And our meter will batch this telemetry data, this metrics, to our backend, to our Elastic backend, where we can look at it in a cube. So we can see like how many requests are coming in that time window. So in order to hook this meter up, we need to copy this key here. And then we go to our configuration. And there you have these guys. And we can say add meter. Then just add the key here. And the internal things here from Microsoft, they essentially just wrap this call and inject constant there for their meters. So there could be a couple of. Can we have a look at that? Sometimes Rider would be nice, but okay. Okay, so we set up our own meter here. And with this, every time we get now data to our meter, it will be reported to the Elastic backend. So there's one more thing. We need to hook up our log or our tracing event listener that we put up. So we say add diagnostics, and then we put in the custom, how did we call it? Logs. This guy here. Let's put it in here. Then restart it. Add instrumentation. Let me just have a look at this. I think this is a problem why our development system doesn't report properly. Fix that. Don't worry, I delete the API keys are my problem in this talk. Okay, we are here. Come on. let's go to the stack management and then stack management, and then we have API keys. There. Let's create a new one because I think that's why my local data is not reported. Copy that. Feed that in here. Okay, let's restart that. And if you ever use .NET Watch and something doesn't work, it's most of the times, and I see that in my demos often, it's because .NET Watch doesn't fully re-execute the source generators. A lot of .NET code, or Chocolate for instance, uses source generators now, and they are not fully re-executed. That's why I always use this no hot reload, but it still somehow is not fully triggered. So that's sometimes when something is not wrong, just restart .NET Watch, just as a tip. Okay, with that, let's just do some refreshes on our local API and hope that we get to see the meters, because that's a really cool and simple way to enrich your telemetry stuff with new data. Okay, this should put pressure on the system. Okay, let's have a look at this. So now we can go to our metrics. And Metrics Explorer. And there we should, let's go to the inventory. Now we should actually now get new data. It's called requests there. That's you can see that here. That's actually what I introduced here. This is my namespace kind of. And this is a counter, it's called requests. You can give it a better name in a proper environment, because when you filter for it, it's just this name. So we want a request counters here for data. Going in. Today from data, let's produce some more. It could be that something is set up wrongly. It happens frequently with this talk. Yeah, it's cloud. Every time you use cloud infrastructure in a talk, that it doesn't work. It's a shame. Okay, it will not work. It will not work. Okay, it usually works when you set it up correctly. Just have one more go at it. Development. Do we get the right data? But also we don't get the correct data from our local environment. So there's something wrong with me uploading to my cloud backend here. It's a shame. Okay, so what you usually would see, say that, and let's maybe we have some historic data. So let's go to May, maybe 30th. In NDC Porto, it worked. So let me have a look. Okay, doesn't matter. So usually we would get a graph over time where we can see how much pressure on our system is. And then we could put now rules on top of these, say, okay, this portion of the graph represents my normal. You could figure that out. And then send me a Teams message whenever the graph moves out of this normal boundary. And you can have a couple of these. Like if you think about a shop API like Amazon, it could be how many checkouts do you have per minute. It could be a lot of indicators combined that you can create. I recommend use meters. It's a nice API. You can see very easy to set up, and it gives a lot of insights in if something works all right. So this is it for the talk, essentially. Let's go back to the slides. I hope you got an idea into what OpenTelemetry can give you, especially with Elastic. We personally use Elastic because it gives a lot of flexibility and is quite cheap in the entry level. Like the instance that I have here was $30 US. So not a big investment if we are talking about telemetry, especially if I remember how we started at the project I worked on, where we had 2 developers working for 2 years on this project. Like they had to develop this stuff, right? It's much cheaper to pay $30 US months. But look at the OpenTelemetry solutions that are actually there. Honeycomb is a very good one. I can also recommend a look at this one, Elastic, and Jaeger. Probably a lot of people also know Jaeger. It's I think it was created from Uber originally. So also a good platform to look for OpenTelemetry tools. I expect a lot more tools in that area to come up over the next years, especially with .NET 7. I expect release versions of OpenTelemetry. So it's a good time to start exploring, even if you're not using GraphQL. Okay. And if you want to follow me or want to connect to our project, take a screenshot and have a good rest of the conference.